Today we're going to go through the beginning of chapter 4 because it's review. So the first thing is that you should be able to do the warm-up, which is ordering rational numbers. And then throughout the chapter, the first 3 sections, it goes through a review of a lot of the 7th and 6th grade math. So I just made up a couple examples, and you guys can ask me questions along the way. But these kind of go with the worksheet I'm going to give you today. So does anybody remember greatest common factor? Okay, a lot of you. All right, so what do you do, Olivia?
Well, you're trying to find obviously the greatest common factor of, well, if you're going to do 36 and 80.
Mm-hmm.
So
How do you do it? Do you have a strategy?
Isn't there like a table you can make?
The ladder.
The ladder.
I like that ladder a lot. You could take your 36 and 80, and maybe not everybody's seen it. It's actually my favorite way, where you just take your 2 numbers and you pick anything common to them. You don't have to get the greatest thing. Just pick anything, like
2.
Okay, 2, like 2. So you put the 2, it's called the division ladder. 36 divided by 2 is 18. 80 divided by 2 is 40. And then you ask yourself, can I do that again? 2 goes in again. So 18 divided by 2 is 9. So you put the result of the division problem below the number. 40 divided by 2 is 20. Is there anything common to 9 and 20? No. Okay. So once you get that, you take these 2 numbers and you multiply them. So 2 times 2 is 4. So therefore the GCF, that's the abbreviation, the GCF of, whoops, it's a 20, right?
Yeah.
Of 36 and 80 is 4. So that's my favorite way because it's quick. Unless you can just see it in your head, which a lot of you can for small numbers. The other method some of you might have used is factor trees, which becomes quite a bit of work because you have to look at all the prime factors, line them up. So I would recommend that you stick with this. And if you don't like this, does anybody really not like this? Okay, you like your factor trees?
Yeah.
And do you know how to do it?
Yeah.
And you're good at it?
Yeah.
Stick with factor trees. Okay, if you want me to brush up on factor trees, I'll do that, maybe at the end of this. Pardon me?
Oh, I remember this.
Yeah, so factor trees work too. So I know sometimes you just like what you like because you're good at it. There's nothing wrong with sticking with that. Here, it works the same way with 3. You could take a 2 out and you get 10, 16, and 9. Nothing else is common to all 3 of these, so it's just 2. It has to be common to everything. Does that make sense? So if there's only one number outside the ladder, then that's your greatest common factor. Yes?
What would happen if, like, you had 3 numbers that went to a different number instead of the number that you just divided by? Is that even possible?
What? Say that again. No, ask me again.
If you did 2 divided by 2, and you got a bunch of other different numbers.
3 different numbers here?
Yeah, but they all went actually to this. Like on a different equation, like you just have different random numbers. But you divided it by one number, but then when they all came out, they could be divided by another number. Is that even possible?
You would keep going, right? Oh, okay. I know what you're asking me. All right. So let's take something like 36 and 80 here. 80, okay? Like 2 goes into these, but so does 4. So you could have just started with 4. You don't have to start with the same thing. So this is a 9, and this is a 20, and then you get there quicker. And the reason I picked those is I just redid the same problem a different way. It works more than one way. Okay, Adam?
Will you ever keep going until you get the greatest common factor at the bottom? Like if instead of 9 that was.
Yeah, let's change it again. Let's change this problem and make it 20, 32, and 48. Okay? Let's say that was the problem, and we started with 2. So we have 10, 16, and 24. We could go to 2 again. 5, 8, and 12. Now these don't have anything in common. So you would multiply these. But these two numbers here could be anything. It could be 2, 5. Is that what you're asking?
Yes.
Okay, so if I had like 32, 20, and 48. Actually, let's make this, let's try 72. If I take out, say, a 2 because it's easy, 36, 10, ooh, let's make this 24. I'm trying to get your situation. I know what you're looking for. I'm just trying to make it up. So 36, 12, and 16. Some of you might take out a 2 next. Others of you might take out a 4.
That's 24, not
Yeah, it's 24.
Yes, it is. Thank you. So you're trying to say, you know, can we do different things along the way, right? Now you could take out a 4 and you would have a 9, a 3, and a 6. Now you can take out a 3, so you have a 3, a 1, and a 2. So now your GCF is, yes, is 2 times 4 times 3. So 8 times 3, which is 24. Did I answer your question?
Yes.
Okay, so it doesn't really matter how you start as long as every step you take is correct. In the end, you're either left with a bunch of numbers and you multiply them, or you're left with one number because you've got it at the first try and it's just the GCF. Okay? This method's kind of nice because there's lots of strategies to get to the same answer, and it's quick. You don't have to do it the same way as everybody else. Okay. All right. Let's go back to this page here. So that brings up the terms just when you do the reading. Prime and composite. What's a prime?
A prime is a number that its only multiples are 1 in itself.
Right. Okay. What's the only even prime?
2.
2, right? So a prime number has exactly 2 factors. One and itself. And the only even prime is 2. So Nandib, what's a composite number?
A composite number is a number that has more multiples, more factors
Right.
than one in itself.
Right. So composite number is any number with more than 2 factors. Right? Yes.
What would 1 be because it only has 1?
It's neither prime nor composite. That's a good question. No, it's just not a prime and it's not a composite. So the smallest prime is 2. And it's the only even. So prime numbers, when we talk about prime numbers, we're talking about numbers 2 and bigger. That's how we look at them. So it's just not part of the set. You know how there's sets in math, right? Like one set of numbers are whole numbers. And they start with 0. It doesn't include the negatives. So the set of primes and composite, it doesn't include anything but integers starting at 2 and counting up 2, 3, 4. Those kinds of numbers. Okay. So mostly you need to know that for reading. Okay. benchmark fractions. When you look at a question like number 4, you should be able to do these without any work. If you can't, you really need to learn them. Okay, especially, well, I would say these two. And then the third one, that was the warm-up. I'll move these up a little bit. So these, you should be able to change a fraction to a decimal. And if it's a benchmark fraction, like a third and 5/8, you should be able to do those without any work, or a little bit of work. If it's 1 and 5/12, then you go back to the warm-up where we did division. So, do we all know this one? What is it, Emilio? Yeah, it's 0.3 repeating, because it's less than 1. If you don't, then do the long division once or twice and you'll remember it. Because you would say 3 doesn't go into 1, but it goes into 10 3 times. It's always good to do the long division once or twice to remember where it comes from. 3 times 3 is 9. When we subtract, we get a 1, so now you bring down the 0. 3 goes into 10. 3 times. 3 times 3 is 9. When we subtract, we get a 1, so you add a 0 and bring it down. 3 goes into 10. 3 times. 3 times 3 is 9, so you subtract, you get a 1 and bring a 0. And hopefully after a while, you're like, oh, okay, I get it. Right? So if you forget, it's not a big deal. You'll remember really quick. Okay. With 5/8, I did this a few minutes ago. If you don't have it memorized, my recommendation is don't do long division. Just do simple, like, number line thinking. If this is 1, that's a half. This is a fourth. And this is an eighth. You know that, right? Okay, so if you know that, and you know, if you think money, this is like a dollar, this is 50 cents, this is 25 cents, and then add a 0 here. Half of 250 is 125. That's often quicker thinking than doing a long division problem. And the reason that's helpful is if we divide everything into eighths here, each little jump is 125 thousandths. So you could just add 125 to 500 to get 6/8, and you would get 0.75. You already know that one. And then add another 125, and you get 0.875. This kind of thinking is, did I put my 5/8?
It's 6.25.
Oops. Yeah, I knew I had something weird there. I skipped one. Okay, so do what I said, but I didn't add right. So take 500 and add 125, and right here, 5/8, you get 0.625. Does that make sense? Sometimes that's a really good way of thinking. I know you guys can do long division, but this might be quicker if you start thinking that way. Because what often will happen is you'll get to this step, and then you won't need to do anything else. You'll just be able to write the answer. Where when you get to 12ths, you got to do the long division. Unless you're very unusual and you have all those memorized. So in the warm-up, I think, didn't we do a 12th?
Yes.
We figured out 5/12ths, right? Yeah, and we didn't figure, did we complete it?
Oh, wait, yeah, that was 9/4. 4/9.
I don't know if we went class 4-1.
Did we finish it? Mm-mm. So 12 goes into 20. We did the 1, right? Twelve goes into 80.
A lot of times.
Well, 12 times 6 is what? Okay. So get an 8, right? There's the repeating, right? So how do you write that? 0.416, the bar is only over the 6. Let's double check my math since we jumped back into the middle of a problem. Make sure we're not careless. See how that? Why is there a 7? It rounds up. The calculator's not able to think infinitely. It has to do something. It's in a panic. I'll just round. Okay, so your answer here is 1.416. Now, nobody really has that memorized, right? No. So the point of this problem number 4 is, if you know it, just write it down. If you think you know it, but you're not sure, maybe draw a number line. If it's not a benchmark fraction, just do the work. But don't do the work on every single one of them if you know it. Mostly just want you to write them down. So in your homework today, you have to do a little bit of work, and sometimes you just write down what you know. Okay? Going the other way, use place value. So like, Emma, if you say this out loud with place value, what's that number here? 1 in 35 tenths, hundredths, right? So write it 1 in 35 hundredths, and then reduce it. What goes into 35 and 100? 5, right? So it becomes 1 and 7/20. Final answer should be simplified. If you know them, just write it down. Right, so the word terminating is unlike the one we just did, the 12ths. The one that we just did with the 12ths, it went on forever. Repeating, right? So this one ends because there's 2 digits. So Matthew just said this is 5/8. He either has it memorized or he at least remembered it from a few minutes ago. Right? Because we did it on the number line a few minutes ago. That little typewriter is making me crazy. A few minutes ago, on the number line, we figured it out. But suppose you don't have that one memorized. You would use place value. So, Cal, how do you say that number properly? Just say the number without the decimal.
625.
625, and count the place value. Tenths. So 625 thousandths. Now divide. How about 25? 25 goes into both of those, right?
Yeah.
So how many times does 25 go into 1,000?
200. No,
400.
How many times does 25 go into 100? 4. So into 1,000?
40.
40. Right? That's what you said, right?
Yeah.
How many? So we know 25 goes into 100 4 times, so it goes into 600
25 times.
24 times plus the one more 25. One more, so it makes it 25/40.
Yes.
Divide by 5. So first, I guess, what did I say? We divided by 25 first. Now we're going to divide by 5, and that's 5/8. So it's handy to have these memorized too, because that's a lot of work. Okay, Easton, say this number properly.
0 and 28.
Right. So if you can say it in English, you can do the math. Divide by 2, or by 4. I'm going to divide by 4. Divide by 4. So 7/25, right? Remember doing that? Okay. Repeating decimals. Again, if you have them memorized, just write them down. This one is 1/3. No. Does anybody know any of these? Come on, I bet Nadeem does. What's this? Have you ever seen this?
Oh, that's one. That's,
Who said that? It's 1.
yeah, because it's 1/3 times 3.
Yeah. There's some other reasons. Does that bug you? It should.
Yeah.
No, it's exactly 1. It's not rounded. Yeah. I know. So does that bug you a little bit? It should. Do you want me to show you why? Okay, but you believe this is exactly 1/3, right?
Yeah.
So
No, because then if you multiply by 3, it's not 1.
Ever.
no, it's exactly 1/3.
Okay, that's just one.
So you don't. Okay, watch. Okay, so let's say we don't know what 0.9 repeating is. Let's call it n. Say we don't know. Say you don't believe me, so we're going to say 0.9 repeating is just n. Can we do that? Okay. In algebra, can I multiply both numbers, both sides of an equation by the same number? Yeah, so how about I multiply this by 10, and then if I multiply this by 10, I get 9.9 repeating, don't I? True? Okay, let's do some rearranging. Can I subtract one equation? Can I subtract? What's 10n take away 1n? 9n. So what is 9.99999 forever? Take away 0.99999 forever. It's just 9, isn't it?
No!
Divide both sides. You gotta go to the end. Go to the end. Gotta do it. What do I have to divide by? 9. So I find out that the value of n is actually just. Whoa, whoa. Remember, n is just 1, but we also said m was 0.9 repeating. So 0.9 repeating is. Okay. One more. So, look at this. You can use that technique to change any of these, and you should. So if I wanted to figure out what 0.4 repeating is, I'm going to say I'll let n be equal to 0.4 repeating. Okay? So I'm going to do the same technique. I'm going to multiply both sides by 10. So I have 10n. What's that equal to? 4.4 repeating, right? So how about I take this and bring it down here and subtract. What do I get over here? 9n. And that's 4, right? And when I divide by 9, I get 4/9. So 0.4 repeating is the same exact thing as 4/9. There's my calculator. 4 divided by 9 is.
Wait, if you
It doesn't have the 5.
Because it's less than 5, right? Didn't round it. So what is 0.3 repeating if you think about it this long way? It would have turned out to be 3/9. Can you see that? And 3/9 is the same as 1/3. One more thing. So the whole reason I did that is to get decimals to cancel. When you look at something that has 2 decimals, you have to think a little bit differently. Adam?
Isn't like, wouldn't it be like 0.5 repeating be 5/9?
Yeah.
6 repeating be 6/9.
That's the pattern. 0.7 repeating would be 7/9. And then 0.9 repeating is 9/9.
But it's not 1.
It is. And when you do calculus, someday, which most of you will, they'll show you another way to believe that. Well, it's true. So between now and calculus, which is about 4 years, 5 years, let's see, for you, you have some thinking to do. Okay, if we do double digits, tell you what, I think that's a good place to stop because that's a lot of information. And I can tell your brain needs to think about that for a day. So what I'm going to do is stop here. Okay.
It's still recording. It's recording.
Oh my gosh, it recorded all that time?
Let's do we got the
Yeah.
little